For the first one, okay, first of all, what is the parent function for that first one? Finn? X squared, so this is a quadratic. Good. Okay. What's changing about the graph? What direction are we moving in? Yep. Good. Moving to the right 2. Okay, remember, if it's in parentheses or the absolute value brackets are underneath the square root, that's affecting the x. Okay? If the x is next to it, it's the opposite of what you see. Okay? Before we move to that one, we're going to do this one here. What is the parent function? Good. Absolute value. Okay. What direction are we moving in? Liam? Left 3. What else? Good. Left 3. And down 4. Again, inside is affecting x values. Outside will be affecting the y values. Okay? Now, for this third one, 2 times the square root of x plus 6. What's our parent function? Yeah. Not cube root. Be careful. The square root. Excellent. Okay, the square root. Okay. What types of transformations are happening? Camilla? Excellent. Vertical stretch by 2 and then up 6. So a number in front of your function is either going to be a stretch, a compression, or something we see in the next one. So again, outside the radical here moves it up 6. Okay. Now this last one is just a random function. Okay. What's one transformation that you see? Yeah. Good. Reflection. Excellent. What's another? Everett? Left 2. Good. Okay. What else? 3. Vertical compression by 1/2. Good. Or vertical shrink. We have heard that too. What else? And then we have the down 10. Good. Okay. The reason I wanted to show you these transformations again is we are getting into graphing exponentials and what they look like. We will be looking at transformations. Hence, for the Delta Math, those of you that did complete it, I know some of the questions might not be a reflection so far of you, just because the misunderstanding of a question or whatever it was, and I will go through it and give you guys feedback. But it's to recall this information. Okay, recall our transformations and how do we move the graph if you're given a new function. Okay, so that's what we're getting into today. Just so you see what the graphs look like. All right, so in the general form of exponential functions, okay, general form of exponential functions, it's written as y equals ab to the x, okay, ab to the x. Now, the a you will eventually see is your initial amount, okay? The b value is going to determine, the one that's attached to the exponent, is going to determine if it's growth or decay, okay? The b value that is attached to the x will determine if it's growth or decay, okay? Now, some key words that we will hear is y-intercept as usual, okay? Domain and range, okay, your initial amount. But one thing that is new to you is called an asymptote, which means it's like a boundary line. Okay? It is like a boundary line. You get very, very close to it, but you never cross it. Think of like an electric fence for dogs, right? If they cross it, what happens? They get shocked, right? So you want to avoid it. Some of them get very, very close to it, just never cross it. That's the same thing with an asymptote, okay? So we're going to come back to this part in 1 second. We're just going to scroll down to the bottom. These two functions are your exponential growth and decay functions, okay? Exponential growth, if you read graphs, you always read graphs left to right, okay? This is increasing, okay? This is increasing. So when you have a b value greater than 1, you have an exponential growth function, okay? So an example of that would be y equals 3 to the x. Okay, that's an example of an exponential growth function, okay? That's an example of an exponential growth function, okay? So few things about exponential growth functions is your horizontal asymptote. Since there is no movement, so your boundary line, if there is no movement up or down, will always be y equals 0. And if you notice, it's written as an equation. Okay, it's written as y equals 0. And we denote it by this little dashed line. Okay, some of you might look at this and say, well, it is kind of touching 0. It's not. If you put it in your calculator and look at your tables, your y values get very, 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 very small. Just never hit 0. Okay? Unless you are moving up or down. Okay? The other key component is your y-intercept. Remember, your y-intercept is when y is equal to x is equal to 0. Excuse me. When x is equal to 0, you will find your y-intercept. And we will have to find that at times algebraically. So that's why you need to know your exponent properties. Okay? Then if you look over to our exponential decay function, an example of a decay function is 1/3 to the x. Okay? So if your b value is between 0 and 1, meaning a fraction, 1/3, 1/2, 1/4, 2/3, okay, you will have a decay function. And reading it left to right, you're decreasing, okay? But again, your horizontal asymptote for decay functions are the same, okay? Horizontal asymptote, your boundary is still y equals 0, and for now, your y-intercept is still the same. So they have a lot of similarities. The directions are just different, okay? All right, so first thing to do is identify if it's exponential growth or decay. We look at that by the b value. So here's the b value for this first one. 1.15. Is that greater than 1? Yeah, okay? So since that b value is greater than 1, what do we have? Growth or decay? Growth. Good. And again, it's based off the b value. Now, to find the y-intercept, we substitute 0 in for x. Well, 1.15 to the 0 power is what? 1. So then we have 8,000 times 1, which is just simply what? 8,000. So our y-intercept is 0, 8,000. Yep. Because 1.15 to the 0 power is automatically 1. Because yep. So no matter what, because it's the y-intercept, just to show you algebraically, okay, because there's no movement, okay? If there was movement, your y-intercept is not always going to be that first value, okay? And we're going to see that. So no matter what, when in doubt, you always plug in 0 for x to find your y-intercept. If there is movement, meaning left, right, up, down, your y-intercept will change. Okay? That's important. I don't want you to get stuck on here's your function and saying automatically that first value is your y-intercept, because that's not the case all the time. Make sense? Bless you. Stefan, you have a question?
I was just going to ask for, like, when you just putting it together.
All right. So if we look at number 2, okay, if we look at number 2, is our b value less than, is it greater than 1 or in between 0 and 1? In between 0 and 1. So therefore, what do we have? Okay, good. We have a decay function. Okay. So now, what is our y-intercept? 20. Okay. Your y-intercept is 0, 20. And we always write our y-intercept 0 and then whatever it is. Okay? Try 3 and 4. All right. So, for the third one, what do we have? Camilla. Decay, good. Because 1/2 is in between 0 and 1. What is our y-intercept? Good. Our y-intercept is 0, 15. Excellent. Okay, number 4. What do we have? Yeah? It is growth. Be careful. Because 5/2, is that greater than 1? Yes. Okay, what is our y-intercept? Good. 0, 6. Excellent. How many of you guys got both of those? Perfect, perfect. Okay, so it's always first. This is going to be more prevalent when we get into word problems, okay? So we are going to look at just graphing these things, okay? The chart above is just recalling transformations, which we kind of just did, okay? But it's something for you to always go back to if you need to. The one that we will not, the 3 that we will not see are the ones that are starred, okay? You guys won't see those, so if you want to cross them out or just leave it where it is, you can. We will not see that one or these, but everything else we have seen, okay? So let's go ahead and graph these guys, okay? So no matter what, anytime you're graphing these functions, any new function, you always want to start with the table of values, okay? You won't need a calculator for this, okay? So I use the standard -2 to 2. That's the table of values I've used for all parent functions, okay? So if I have, here we have 2 to the x. So the -2 is in the exponent, okay? So we have 2 to the -2nd. What would that be? Excellent, good. Because the negative exponent, 1 over 2 squared, which gives you 1/4, okay? How about 2 to the -1st? 1/2. 2 to the -1st is 1/2. How about 2 to the 0? Yep. 1. 2 to the 1st, 2. 2 squared is 4. So we're going to go ahead and graph those points. One thing to keep in mind, they're fractions. Do the best you can, okay? So we know that negative 2 and 1/4, just kind of estimate, okay? It's below the 1. Negative 1 and 1/2 is there, and this is off. 0, 1, 1, 2, and 2, 4. Okay. So this is what the function looks like, okay? And keep in mind, it does not cross that x-axis, okay? So remember that you have a horizontal asymptote at y equals 0, okay? You have a horizontal asymptote at y equals 0, okay? Horizontal asymptote at y equals 0. Now, looking at this function, what is our domain? What is our domain? Tyler? Excellent. Negative infinity to positive infinity. Now, what is our range? Stefan? Good. What's going to be around the 0, though? No, not the asymptote. When you write your range, you are correct. 0 to infinity, right? What am I going to put around those? Brackets, parentheses. Okay. Finn? Parentheses around both. Because does it touch 0? It gets very, very close to it. But we can't pinpoint the smallest value it's going to be. So we use what we know. We use our horizontal asymptote, which is 0 because there's no movement up or down. And that is going to match my range. But I need to have parentheses. If it was a bracket, that means it would include 0. Okay, does that make sense? Okay. So what is our y-intercept? What is our y-intercept? Liam? 0, 1. Good. Okay. So y equals 2 to the x can be an example of one of the parent functions. But obviously that can change. 2 to the x, 3 to the x, 4 to the x. There is no 1 to the x. Keep that in mind. Okay? So this is an idea of a parent function, especially if you have something like this. Y equals 2 to the x plus 3. What do we think? What's happening to our new graph? Yeah. Okay, 3 to what? Okay. Think of your transformations. Yeah.
I think the y values might all increase by 3, or like the whole graph.
Okay. Yep. Okay. Good. How many? There was a lot of suggestions here. What do you guys think? Are we moving up 3? Are we moving right 3? Are we, by adding 3, are we moving to the left 3? Stefan is correct. Okay. We are moving to the left 3. Okay. So, again, our exponent, we have x plus 3, which is the same as if we had 2 lines for absolute value, underneath the square root, in parentheses for quadratics, okay? It's in the exponent, but still the transformation stays the same. So, our parent function is 2 to the x, okay? Our parent function is 2 to the x. So we're taking these original values and moving to the left 3. But out of these values, What changes? X or Y? The X changes. So our Y values will be exactly the same. So if I have -2 and I'm moving to the left 3, where would I be? Yeah. -5 and 1/4. Okay. Instead of -1, I'm moving to the left 3. Where would I be? -4 and 1/2. Good. 0. Moving left 3. Where would I be? This? -3, 1. Excellent. Okay. 1. Moving to the left 3. Yep. -2, 2. Okay, and the last one will be -1, 4. Okay, so we just moved to the left 3. Now, some of you might automatically plug in these values. Okay, so if you were to plug in those values to the equation, okay, you have -2 plus 3, which is 1, right? So 2 to the first is 2. So -2, 2, if you just plug in these values, you are not going to see those bottom 3 points. So that's why it's important to graph the parent function first, then move it over. Or do the table of values, then move it over. The reason is, if you stick these 5 values in here, you are only going to see this part of the graph. You're not going to see the whole thing. Okay? So, since we moved to the left 3, out of these guys, what stays the same? Yeah. Hmm? Okay, we're not using slope here. We're not using slope. Yeah. Your domain stays the same. What else stays the same? Yep. Yep. The range stays the same. What else stays the same? Yep. The horizontal asymptote, which is y equals 0. Now, we have to find the y-intercept. How we do that is what? What do? We don't have it shown on these 5 points, so we have to find it. Yeah. Plug 0 in for x. So when I substitute 0 in for x, I have 0 plus 3. What is 2 cubed? 8. So our new y-intercept is 0, 8. Okay, our new y-intercept is 0, 8. Okay, so this is a case where everything stayed the same. However, you had to find your y-intercept by substituting it in. Okay, let's do a few more. Okay. So again, we're going to start off. We have 1/2 to the x, so automatically, what type of graph do we have? Growth or decay? Excellent. All right. So, we have 1/2 to the -2nd. What do we end up getting? So when you have 1/2 to the negative second, the negative second has to go to the numerator and the denominator. But can we have negative exponents? No. So therefore, since the top has a negative exponent, where does that go? To the bottom. Okay, so we have 1 squared. Since the bottom has a negative exponent, where does it go? To the top. What is 2 squared? What's 1 squared? 1. So we end up with 4. Okay? We do the same thing, 1/2 to the negative first. Yeah, Liz. 2. Excellent. Okay. 1/2 to the 0. Just 1. 1/2 to the first. 1/2. 1/2 squared is 1/4. Okay. So -2, 4. -1, 2. Okay. So here's our decay function. What is our domain? Chris, what's our domain? Good. Tate, what would be our range? Yep, look back, look back. Yep, it would still be the same, okay? Just because it's a different direction, it doesn't matter. It's still your y value, 0 to infinity. What is our horizontal asymptote? Rob? Yep, y equals 0. What is our y-intercept? Good, 0, 1. So again, are those the same characteristics as what we just saw? It's just going in the opposite direction, okay? So now we're going to see, how is this graph going to change? Go ahead, Everett. Excellent. Okay. You are moving up 3 because it's outside. Okay? So what are changing? Your x or your y? Your y. So all of these values, what are we doing? Adding 3. So -2 what? 7. Good. -2, 7. Okay. -1, 5. 0, 4. Then we'll have 3.5 and 3.25. Okay. Okay. What is our domain? Yep, -infinity to a positive infinity. Now, what changed? You'll get it. Horizontal asymptote, yes, has changed to what? 3. So your horizontal asymptote is y equals 3. Okay, your horizontal asymptote now is y equals 3. So if I know that, what is my new range? Yeah. Excellent. 3 to infinity. Okay. So now, our y-intercept is what? Go ahead, Em. 0, 4. So, out of these guys we just did, okay, moving left to right, does that change your horizontal asymptote? No, right? It's still going to be what? 0. Moving up or down, does that change it? Yes. Okay. So you guys are going to try 2. Actually, 3 on your own. Okay. You're going to try number 1, number 2, and number 4. Okay. 1, 2, and 4. We're going to do 3 together. 1, 2, and 4. Okay. Give those a try. Start with your table of values. Starting with -2, -1, 0, 1, and 2. Okay, give those a try. Okay, let's go through these. Some of you are probably just finishing up, which is fine. Okay, if we look at number 1, this would be considered a parent function, okay, that we're always referring back to. This is what we should have gotten based on our table of values. Okay, so we're going to go through domain, range, horizontal asymptote, and y-intercept for all. Okay, what is our domain for all 3 of these? Yeah, Mia. Good. For all 3, good. Okay. For this first one, what is our range? Good. 0 to infinity. What is our horizontal asymptote? Porter, what do you think? Good. Y equals 0. What is our y-intercept? Emily?
1.
Good. 0, 1. Excellent. Okay. So we should have got this for the first one as our parent function. Okay. Now, looking at number 2, we moved up 2. Okay. So what is going to change? Rob. Good. The horizontal asymptote, which is what? Is excellent. Y equals 2. Therefore, our range would be 2 to infinity since we moved up. What is our y-intercept, Nick? 0, 3. Excellent. We took our original, okay, and just added 2 to it. All right? How many of you did get 1 and 2 correct? Good. Okay. Number 4 is very similar. However, we're moving down. So what is going to change? Finn? Good. What is the horizontal asymptote? -4. So y equals -4. What is our range? -4 to infinity. Excellent. What is our y-intercept? Nick? 0, -3. Awesome. So we took our originals and subtracted 4 from them. Okay? How many of you got that one correct? Okay. So now, number 3 I left as is, okay, for us to do. Because what transformations are happening? Yeah. Good. Vertical stretch by 2 and a reflection. Okay? So, I'm going to just copy down our original y values and x values. 1/9, 1/3, 1, 3, and 9. Okay. So since we have a vertical stretch by 2 and a reflection, what do we have to do? Those could be done at the same time. Everett? By negative. Excellent. What values? X or Y? Good. Nice job. So we're going to take our original y values and multiply it by the reflection in the stretch, the number in front. Okay? So You're multiplying your y's by -2. All right, so we have -2/9, -2/3, -2, -6, and -18. Okay, so 0, -2. Okay, 1, -6, and 2/18 is somewhere down here somewhere. And then 2/9, or 2/3, 2/9. This is what it looks like. Okay. What is our domain? Yeah, Everett. Excellent. So that will remain the same for all exponentials, growth or decay. Okay. What is our range now, though? Excellent. -infinity to 0. Okay. That is the big change. -infinity to 0. What is our horizontal asymptote? Y = 0. Still the same. What is our y-intercept? Go ahead. 0, -2. Okay. So we went through exponential growth and decay graphing functions. Okay. You did identify domain, range, horizontal asymptote, and y-intercept. Okay. You do have practice. Okay. Starting on page 4. Okay. So on page 4, in your notes, 5 through 8. Oops. Page 4, number 5 through 8. Page 5, there's 1 through 6. Okay, so on page 4, 5 through 8, numbers 5 through 8. Page 5, 1 through 6, page 6, 7, 8, and 10. All of these, I know it does not mention, but all of these, I want you to include domain, range, horizontal asymptote, and your y-intercept. Exactly what we did in class. Okay? Start off with your table of values. So page 4, 5 through 8, page 5, 1 through 6, and page 6, 7, 8, and 10. Identify domain, range, horizontal asymptote, and y-intercept.